Lesson 6-1, Graphing Systems of Equations. Our essential question is, do all systems of equations have one solution? The first vocab word is system of equations. A system of equations is just two or more equations put together. The solution to a system of equations is an ordered pair that is a solution to all of the equations in the system. The systems that we're going to be working with in this course have two equations in them. When you're in a more advanced course, you'll see systems that may involve 3 or 4 equations. Remember that an ordered pair has an x-coordinate and a y-coordinate. So what we're looking for when we're looking for our solutions would be those ordered pairs. Okay, use the graph below to answer the following. What kind of lines are formed? How many solutions does this system have? And if there's one solution, name it. So by looking at the graph, the two equations that we're working with are down here at the bottom. So my first one is y equals negative 3x minus 5. And my second one is y equals 2x minus 5. So I need to locate these lines on the graph. So the first one I see is green. So this one's green. And then the second one I see is blue. So the green line and the blue line. If I look at those two lines, their relationship to each other, because you notice the green line is going like this, and then the blue line like this, those lines are called intersecting because they cross. So these are intersecting lines. They intersect at one point, so that means that they have one solution. There's only one ordered pair that they share, and by looking at my graph, it's a little bit hard to tell. So if I put a couple of marks in here, maybe it's negative 1, 2, 3, 4. So I can't tell from my grid on the board. To me, it kind of looks like it's 0, negative 4. If you're able to tell from your packet, it might be 0, negative 5. So just look at your grid, and it might be a little easier to read in the packet. Okay, our next one, 4x minus 2y equals 10. And then y equals 2x minus 5. So what color is the first one? The first one I see right here is pointing to the line that is blue. So this one is blue. And then the second one is also pointing to the line that's blue. So these equations actually represent the exact same line. So that means that the lines are identical. It's kind of like twins. Identical, and that means that there are infinitely many solutions because there's not just one ordered pair that they share, they actually share every single point on the line, and there's an infinite number of points on the line. So when the two equations actually represent the same line, we call them identical, and they have infinitely many solutions. Okay, the next one, we've got y equals 2x minus 5. So that's our blue line again, right here. And then the second one, 4x minus 2y equals negative 4. I do not see an equation that matches that one. So what that means, if you don't see an equation that matches, that means that you need to solve it. So if I put this in slope-intercept form, I would subtract 4x on each side and bring down negative 2y equals. Keeping it in slope-intercept order, I need negative 4x and then minus 4 after it. Remember that those are not like terms, so you can't combine them together. Then divide everything by negative 2 so that the y is alone. Negative 4 divided by negative 2 is 2, so 2x plus 2. So now I can tell that this is the red line right here. So the blue line and the red line, their relationship to each other, those lines are called parallel. They have the same slope, but they have a different intercept. They don't ever cross, so that means that there's no solution, because the solution is the point that's a solution to both lines. So it's like where the lines intersect, that ordered pair that's on both lines, and there aren't any because they don't cross. Okay, next one. Y equals negative 2. That line is purple right here. And then the second one, y equals negative 3x minus 5. That one is right here, so it's green. So the purple line and the green line cross right here at this point. So what that point looks like to me is negative 1, negative 2. So those are intersecting lines. Intersecting lines have one solution. And that solution is the point where they cross. So negative 1, negative 2. Next example. That's y equals negative 3x minus 5. That line is green. And then the next one looks like I need to solve. So I'm going to get this one into slope-intercept form by subtracting 6x on both sides. 2y equals negative 6x minus 10, and then divide everything by 2. So y equals negative 3x minus 5, which happens to be the same as our first equation now, so it's also green. So these lines are identical, and there are infinitely many solutions. Okay. Now we have a click and drag. I'm going to put the graphs in first. It doesn't matter what order you put those in. When the lines are parallel, there's no solution, and that happens when you have the same slope but a different y-intercept. When the lines are intersecting, there is one solution, and that happens when your slopes are different. And then when you've got only one line in the graph, the lines are identical. There's infinitely many solutions, and that's when everything ends up the same. You can't tell that they're the same usually unless you write them in slope-intercept form. So write them in slope-intercept form, and then you should be able to tell that your lines are identical. You should be able to write a summary now, so make sure that you use complete sentences and answer the essential question.